Hello. Most of you may remember the final scenes of The Wizard of Oz, when Dorothy and her assortment of friends experienced the disappointment and bathos of discovering that the Wizard of Oz was just an old guy behind a screen. I think the same can be applied to the discovery of the Higgs boson. Given that the standard model of particles is bound up with the modern cosmological creation myth of a Big Bang, it seems appropriate to continue the quasi-religious terminology with a God particle. But what if the Big Bang is just that, a convenient myth? The book by Eric Lerner, The Big Bang Never Happened, published in 1991, argues strongly against this event. One of his principal arguments is based on the correct understanding of the second law of thermodynamics. The second law has been expressed in a number of different forms. 1. That systems tend towards disorder, and the amount of disorder is described as entropy. 2. That systems tend towards equilibrium, and this is the state of maximum entropy. This is a counterintuitive argument because equilibrium seems more ordered than disordered. But for example, in the periodic table, the inert gases are all at the far right of the table, and they are inert because their shells of electrons are complete. That is, they have no inclination to interact with other atoms, and all the other atoms strive by intersharing of electrons to become similar to these inert gases. So it is said that everything is tending towards disorder, which is really a state of inertia or equilibrium. 3. Boltzmann found a different expression based on probability and statistics in his famous equation S equals K log W, which meant that disordered states were more probable than ordered states. A key feature of the first two descriptions was that the process towards disorder, equilibrium or maximum entropy, was irreversible and produces an arrow of time pointing from the past to the future, whereas in Boltzmann's formulation, the process could theoretically be reversed. That is, the movement from disorder to order was not impossible, just highly improbable. The theory of the Big Bang is based around this arrow of time, and it is argued that as the present state of the universe is disordered, it must have evolved from a highly ordered state, or singularity. This singularity is reckoned to have been around 14 billion years ago. The fact that some objects in the universe are older than this doesn't seem to have had much impact on the theory, as it should have had. It also predicts the universe reaching a maximum entropy. But it also does not sit comfortably with the view of particle theorists who claim that at the atomic level all processes are reversible. So it is a very muddled picture. This muddle can be extinguished very easily by limiting the application of the second law in its various formats to closed systems, that is, with finite amounts of energy and space. At page 289 of his book, Eric Lerner states, quote, "The universe, just like our own planet, appears to be moving away from equilibrial heat death towards higher energy flows, away from a homogeneous distribution of matter towards increasingly complex structures, and away from slow change to faster rates of evolution. The universe we observe is simply not decaying. The generalization of the law of increasing disorder to the entire universe is unsupported by observation." Once the Big Bang theory is jettisoned, then the prevailing theory of matter departs with it, a sad exit by the whole congregation of particles, including the Higgs boson. Eric Lerner states at page 329 of his book, quote, "The Big Bang serves as the principal justification for constructing giant particle accelerators, such as the $10 billion supercollider, as the main tool used to probe the structure of matter. The vast energy of particle collisions in these accelerators, physicists argue, can reproduce the extreme conditions of the Big Bang and thus penetrate the very origins of the cosmos. The interdependence between fundamental physics and cosmology extends to method as well. Like cosmologists, theoretical particle physicists rely heavily on the deductive method. deriving their theories from the perfect symmetries of mathematics, which, because they aren't based on observations to begin with, can't be effectively challenged by experiment. If the Big Bang is wrong, then many of the basic ideas of fundamental physics are wrong as well. The same methods that have led cosmology into a blind alley have also simultaneously stalled the advance of knowledge of the structure of matter and energy." Close quote. Returning to the God particle, various scientific magazines have questioned the explanatory power of the Higgs boson directly. In the New Scientist, 7th of August 2020, Leah Crane states, quote, "The Higgs boson, discovered at the CERN Particle Physics Laboratory near Geneva, Switzerland in 2012, is the particle that gives all other fundamental particles mass, according to the standard model of particle physics. However, despite the work of thousands of researchers around the world, nobody has been able to figure out exactly how it does that, or why some particles are more massive than others." Close quote. And from Science Alert, 23rd July 2024, Mike McRae states, quote, "They called it the God particle, a particle so goddamn elusive it took nearly 40 years and a $4.75 billion machine to detect it, all in the hopes of closing one chapter in physics and opening a new one. Yet for all its promise, it's possible the Higgs boson might not be the window into a new age of science. On including previously neglected corrections to data-driven models of the Higgs boson's creation, physicists from the Polish Academy of Sciences, the Max Planck Institute for Physics, and the RWTH Aachen University in Germany have failed to find evidence of hidden laws lurking in the particle's shadow." Close quote. Notwithstanding the fruitlessness of the endeavour, there are endless panegyrics on the subject, online and on Peter Higgs, who, to be fair to him, appeared mortified by all the possibly unwarranted attention. The argument for such a particle is circular, or involves an infinite regress. The Higgs boson is a particle with mass, which is obtained through its own field, though how it can generate a field to generate mass prior to its having mass is a puzzle. And from there it imports mass to other massless particles. Isn't the very concept of a massless particle a contradiction in terms? But of course light is treated as being a stream of massless particles or photons, a hypothesis that may have some heuristic benefits but not ontologically correct. Light, to my mind, will always be a self-propelling transverse electromagnetic wave. Even in 2012, around the time the discovery of the Higgs boson was made, a number of physicists had doubts about the existence of such a particle. An article in The Atlantic of July 17, 2012 by Robert Wright stated, quote, "Decades ago, physicists had found a way to unify, that is, fit into a common theoretical framework, two of the four basic physical forces, the electromagnetic force and the weak nuclear force. But there was one hitch. Photons, the particles that mediate the electromagnetic force, have no mass, whereas the particles that mediate the weak force, the W and Z bosons, seem to have mass. This theoretical unification wouldn't make complete sense unless the W and Z bosons were, like photons, massless. So here comes the suspiciously convenient part. Physicists supposed that maybe the W and Z bosons didn't really have mass. Rather, there was some feature of the universe that made them behave as if they had mass. That something was dubbed the Higgs boson." End quote. So, in the mathematical pursuit of symmetry, the article continues, quote, "Positing the existence of the Higgs particle field struck some physicists as a bit kludgy, a kind of Deus ex machina wheeled onto the stage to salvage an otherwise incomplete plotline." End quote. The situation is similar to the medieval monks arguing about how many angels can fit on top of a needle. The menagerie of particles reminds me of the medieval heavens, occupied by increasingly higher, fanciful elements, from Lucifer to seraphim. It is time to recognise, as many physicists now do, that the Standard Model has strayed from the scientific method and are adopting Ptolemy's procedure of adding more and more particles, forces and fields to keep their theory working. They also rely on the shaky foundations of the Big Bang theory and the misapplication of the second law. Instead of looking for new approaches which do exist, these vested interests are doubling down and at great expense chasing fantasies such as gravity waves and neutrinos and so on. The alternatives, such as plasma physics, fractal models of the atom, and supplanting gravity as the driving force of the universe with electromagnetism, all seem more promising areas of study. I'll end with an interesting footnote that one of the many sidelined physicists, Alfred North Whitehead, developed a general theory of relativity based on or including electromagnetism, processes and experience, which for some time competed with Einstein's GTR, which was based on a mathematical formulation of space-time, gravity and matter. Perhaps it is time to revisit some of Whitehead's ideas. Thank you for listening, and I hope it has provided some food for thought.